Thank you so much and good afternoon. Kavita gave a good primer in terms of what you can expect in this session. So the objective of the session is to go slightly deeper into threat detection and response. Yeah. So cybersecurity threat detection and response is a complicated domain which we all have been trying to simplify for last many years. Yeah. So we have taken a lot of baby steps and we have come here. So this session is all about how we have applied AI, GenAI and Agentic AI in cybersecurity threat detection and response. So if you can move on, Balan. So quick agenda. So what we will cover? Yeah. So I will give a very high level basics of how threat detection and response works. So then we will look at how this domain has transformed over years, right? So a lot of work has been going on in this domain. We all know GenAI and Agentic AI came very recently, but AI and ML has been in this domain for a very long time. Yeah. So we will just look at how it got transformed. Then we will look at some of the use cases that we have successfully applied, and we will do a quick demo also. So towards the end, the last 10 minutes, we will do a quick demo, and then I will summarize all the use cases when I conclude. So let's look at how threat detection and response works. Yeah. So very simple diagram that I have just given here. So you have all the servers, network devices, security devices, applications. So everything is sending telemetry logs, right? The logs then get into an engine where the engine is actually identifying the threats. So you have use cases, and those use cases are essentially identifying the threats. And finally what happens is, once these threats are identified, there is a team sitting there. So you call the SOC team, Security Operations Center. So this team is essentially what they are doing is they are acknowledging, aggregating, they are correlating, they are assessing the threat, they are prioritizing, and eventually they are raising an incident. Okay. So even though the threats are identified by a system, a lot of work is being done by the people on the front. Okay. Because traditionally the threat detection and response is full of noise. Yeah, you get a lot of false positives. We always say that in the world of security, identifying a threat is like identifying a needle in a haystack. Yeah, so there is so much of noise and so much of alert fatigue. So this job is generally considered to be highly stressful, and it generates a lot of fatigue. Yeah, Balan, if you move on. So what are the business challenges generally faced in detection and response? If you see, first and foremost, like I said, high false positives, very high false positives, alert fatigue, so people get really tired. Okay, so they can't do quality jobs. See, constantly they are dealing with a lot of flood. Okay, and low detection accuracy. Because of all the false positives, many times genuine threats are ignored or missed. Okay, so business impact, if you see, increase in MTTD, the mean time to detect a threat, which is MTTD, it is constantly always on a high. Yeah, Balan. For response, see, you detect, then you have to respond. So when we say respond, you have to either contain or resolve that threat, right? So there the problem is that time consuming to triage and investigate. Okay, so since the person is expected to do this manually, right? So a lot of time is spent in doing this, and a lot of inconsistency, because it all depends on this individual's technical capability to do this investigation. So a lot of time is lost there, and difficulty in assessing the business impact, and it becomes complex when there is a large scale attack. Yeah. So I have practically seen, if there is a cyber attack that happens, continuously there is an attack, people find it very difficult to actually do the response properly. Here the impact is MTTR. So time taken to respond takes a beating, and that's the major business challenge. Balan. So let's go back, yeah. So we will go one step at a time, yeah. So the logs, like I said, the logs goes into a traditional engine. When I say traditional engine, this is like few years back, we used traditional engines to detect threat, and once the threat, the alert is nothing but threat, then the people on the top I have written triaging, the people are involved in triaging and raising an incident. So typically it takes 120 minutes, on an average it takes around 120 minutes to do this work, and then you have to respond, and the response is also manual in nature. So this is like few years back, that's how it was done, Balan. So few years back we introduced ML, okay. So in the form of use case called UEBA. UEBA is user and entity behavior analytics, right? Simple is whether a user is compromised or a device is compromised, that's it, right? So this was introduced with a very clear objective of improving the detection accuracy and reducing the false positive, right? So we are still in the detection stage. So ML was introduced few years back, Balan. So what did we do? So in ML, so what did we do? So the device and the user telemetry, right, is collected, and three major activities happens now, okay. One, behavior analysis. So what is behavior analysis? So there is a certain behavior of a user, okay. So let's say the user is logging in from always 9 to 5, right? Suddenly they start logging into the system midnight, that's a change in behavior, okay. Suddenly they log in from a different country, change in behavior, right? Suddenly they do an impossible travel, right? So today they are in Chennai, in few hours they are logging in from San Francisco, then it's a impossible travel. So these are all behavior related issues that are identified. And then there is a device fingerprinting. When I say device fingerprinting, the device also shows certain behavior, okay, your laptop, a user behavior, the device behavior, that is also captured, and then we also then take into account threat intelligence. A lot of threat intelligence is collected across the world, and we take that, and that is also added, right? And finally the alerts are then generated. Again there is a lot of false positives, okay. So please imagine, right, I suddenly wake up in the night and I start working, okay. So doesn't mean that I am compromised as an user. So we all do that, right? And then in my case, I keep traveling, I do a lot of international travel. So I suddenly log in from a different country, the device, the ML will say that it is deviating from my standard pattern, and many such things can happen with me. Yeah? So still it doesn't mean that I am compromised, okay. So what we then do is we started applying a risk score and criticality, okay. For every activity there is a risk score attached and there is a criticality given, just to reduce the false positive. The way we calculate the risk score is our IP, yeah. So that helps us stand out from the crowd in terms of reducing the false positive, then eventually the incident gets triggered, okay. So this is at a very high level. So Balan, if you go to the next slide. So these are the use cases, right. So how we are doing today, user device compromise, which is UEBA, where we apply risk and criticality, and the output is more accurate threats and less false positives. And if you see in the right hand side, multiple failed logins followed by successful login during unusual times, login from different device than normal, login from different geolocation than normal, right. And on top of that, if a device is compromised or if a user is compromised, they are going to do something in the system, yeah, in your machine. We also have the baseline of the machine. Suddenly you start executing a process which is not there in the organization or rarely used process in the organization. All these things are all deviations from the standard. With help of risk and criticality, then we apply the score and identify whether this threat is genuine or it is a false positive. Okay, so this took care of detection. Okay, so we have implemented UEBA almost 3 years back. Today the level of accuracy that we have is very, very high. We will show a demo as well that how we have done. So this is the architecture. So this is the technology behind UEBA. Yeah, Balan, you wanted to so give a quick overview. Yeah.
Okay. So thank you, Mahendran. These are all the background of whatever Mahendran is saying is the architecture, whatever we have shown here. Basically, this architecture involves the machine learning models, the data engineering pre-processing, and then the data validation, everything, and then sanitize the data, and then we are putting into the model. So model we used, the clustering models we have been used, and then the random forest we used. See, it's based on the use cases, we have chosen the model, and then we are predicting the alerts over there. Basically, the data which comes from the machine, it's a logs. Okay, so from there it comes to the data lake part with the forwarder. We are using the forwarder to send the logs to the data lakes. From there, we are picking the logs, and then we are applying the algorithm, the machine learning algorithm, to detect the alert. See, whatever that Mahendran explained, right? The different use cases being applied here, and then we are putting into the again to the data lake. So from there, we are showing in the UI, and then the next level is we are putting into an incident with the help of SOAR, automated responses, and then we are doing the remediation part. This is the complete architecture of the ML part. That's all.
So that took care of detection for us. Now response, right? So now you have detected the threat, then you have to reduce the time that you take for investigation. So if you see, that's where we introduced GenAI and Agentic AI. So today, GenAI, once the threats are identified, it goes through GenAI model. The GenAI is fine-tuned in such a way that it will quickly do the investigation, and it will tell the analysis, and it will give a recommendation. Generally, like I said, it takes almost 2 hours for people, depending on the complexity, to do this. Now it happens in just fraction of minutes, 2 to 3 minutes. We will show the demo as well, how it happens. And we have also introduced Agentic AI to complement GenAI, so that also we will give a demo. So ultimately what we need is identify the threat and quickly convert that threat into an incident so that the customer can take action. So this entire process today is fully automated. So if you see what is the outcome we have achieved: automated triaging, MTTD, time to detect the threat, is today on an average less than 10 minutes. In some cases, it is just fraction of seconds. Quick turnaround. So once we identify the incident, if we can give proper clarity to the customer, then the customer can take action. Wherever automation is enabled, automatically the response also happens. So this is the architecture behind our GenAI and Agentic AI. So Balan, you want to?
Okay, so I think most important part here. So last year we started investigating the right models to solve our use cases. Okay, and almost 8 to 9 months. Keep on training the models to get the right output. That is very challenging, because the cybersecurity side, LLM models and all, right, it is not providing a very good output. Okay, we put a lot of effort over there to train the models and provide. Now the result is almost 95% of accuracy we are getting now. This is the architecture we are using. So you pretty much you know, when you have an AML background, you could have known that all the sentence transformer and hacking phase transformers, and then we are putting into the knowledge base, and there is a RAG which is orchestrating our processes, and then LLM model we are using. Various LLM models we tried. We started with Llama 3, DeepSeek, and Quen we are using now, and so many models we tried, and for the different use cases we are trying the different models. And the Agentic AI part, the Crew AI is the one framework we are using to provide the Agentic AI solutions. So from there we are doing the security posture. So we will show the security posture with the Agentic AI, how it is being used, and then we are creating an auto incident. The health check, we have a PDMA report, so that report will be monitored by the agent, and it will provide a human based results. So that is where we are using Agentic AI, and from this we will be quickly, we need to respond, right? So we are giving an option to provide it in the chat so that we can respond it immediately. So this is what the architecture behind it. The top one is the source of the alerts we are getting for the models.
So now with all this in place, so this is now our next generation threat detection and response architecture. So at a very high level, if you see, I am just summarizing it now before we go to the demo. On the left hand side, you can see all the sources where the telemetry is coming from. Traditional engines are still there. For certain use cases, it is still very, very effective. We have complemented it with ML, UEBA. The threats are identified. It goes through one more engine, so it's called PROACT Extended Threat Detection Engine. There we have Agent and GenAI working together, and the key differentiator is context and enrichment. Okay, so what is context and enrichment? See, let's take an example, right? You take a bunch of alerts, right? From any source, you take a bunch of alerts, put it in ChatGPT, right? Let's say your web application is getting attacked, and you have all these alerts with you. Take these alerts and put in ChatGPT. It will give you a beautiful response. You tell I need analysis, recommendation, it will give you a beautiful response. Okay, but what the ChatGPT doesn't have is the context. Okay, if there is a web attack, ChatGPT is going to tell, hey, as a recommendation for remediation, you should go and fine tune your web application firewall. Okay, right? That will be its standard response, right? And in the reality, if you see, if the customer or the enterprise doesn't even have a WAF, okay, how will the ChatGPT know? So it is missing critical technical context and business context. So it output is always going to be generic. Okay, but since we are doing in the enterprise, we will be able to give this context. So I can tell, hey, the customer has a WAF. Okay, now the model, our model will understand, yeah, there is a WAF, I have to give a recommendation for a WAF. I can tell there is no WAF. Then the recommendation will always tell that you need to first implement WAF. Okay, so this level of context, business context, okay, during Amazon Big Billion Sale, right, certain threats are very, very critical. You can't ignore. Okay, so during that time, if I have the business context for my customer saying, hey, this period is very, very important, certain threats will be taken very differently and will be handled very differently. Okay, so the success of this model, okay, GenAI and Agentic AI largely depends on the context that you provide and the enrichment that you provide. So once that happens, your accuracy greatly increases. Yeah. So this is the final architecture that we have today, which is working very, very effectively for us. So now what we will do is we will quickly go for a demo. Yeah, Balan. So so before Balan starts, so these are threats. Okay, so if you see, these are aggregated threats, right? This is what the team on the ground is going to see. Okay, so Balan is picking up one threat. Balan, if you go to the left hand side first, just show the name of the threat. Yeah, so defense evasion attack observed for the same user. So this is this is an aggregated threat. Yeah, so he will show what all has happened there. So go to the right, Balan. Yeah. So if you see, this thread has a number of alerts inside this thread. Okay, so he is aggregating. You can see a lot of activities that has happened in the Linux environment. So some are probably genuine activity, some are not genuine. It is a threat related activity. Now this is what the person sees on the ground. So now the practical difficulty is, with this he should be able to do an analysis, he should be tell what is the business impact, he should create a recommendation. Okay, sometimes you see this is a very small number, sometimes you will have 500 different alerts in this. Okay, so that is too much for someone to actually quickly think and react. It completely depends on the person's skill set. Okay, so now what we will do is, we will send this to our AI model. Yeah, so Balan. So we have given an option for people to use AI. So just they have to click AI. Then what happens is that in the back end it starts running. It will take a couple of minutes. So before that, while it is happening in the back end, so we will move on. Right. So this is our UEBA output. Okay. So please remember, the other one is running. We will come back. Like I said, in UEBA we have risk score. Okay. Based on the risk score, the false positives are reduced. If you see here, there are 3 colors you can see. One is a red on top, then you have an amber, then you have a blue. Okay. The blues are the ones that you can safely just ignore. Amber is the one you have to probably look at. Red is very important, you have to analyze. So if you go to the red one, Balan, just pick up one please. Yeah. Yeah, so you see here, there is something called Windows process anomaly. So if we expand that, it will say what are the processes that has run in this system. Okay, if you see there are command line process, critical process, just select something Balan. Yeah. So if you see critical process, so somebody is trying to modify the registry. You generally don't do that every day, right? If someone has done a modification to the registry, the risk score is now increased, along with many other activities they have done. Okay, and Balan, if you want to, yeah. So now that is user, this is entity. Okay, so if you see, it shows IP address. IP address means it's a machine. Yeah. So here, if you see, we are seeing traces of data exfiltration. So what is exfiltration? Somebody is trying to take the data out from this machine, right? So that is identified. So 284 hits has happened there, and the system has now identified that this is exfiltration based on the baseline that it has created. See, every day you are uploading some data, you are downloading some data, it clearly understands that this activity is not genuine, something is wrong. Okay, then it has increased the risk score. Yeah, that's what you see on the top. And reconnaissance, so there are 2 activities you can see. One is exfiltration and reconnaissance. So that means somebody is trying to understand what is happening in this machine, and subsequently they have also tried to go inside and take the data out. So 2 sets of activities has happened in this case. Yeah. So this is what we call UEBA, user and entity behavior analytics. Okay. So this helps significantly reduce the false positive because of the risk and criticality, so that these alerts are then taken care. Okay. So Balan, you want to, yeah. So the model has now done the analysis. So it is giving a very clear description. If you see what has happened, one second Balan. So it clearly says these are the set of activities that it has observed in this machine. Go to analysis please. Now for each activity, the model is telling what has happened with that activity. Okay, very detailed, right? So 1, 2, 3, 4, 5, 6, all the activities it is giving us analysis, and then if you come down, it is giving a chronology, right? It clearly gives you a timeline, chronology, right? What happened first, what happened last. So everything is here so that the person on the ground can understand very quickly. And then there is a recommendation as well. So if you click recommendation, the recommendation is here where it clearly tells what you have to do. So it says investigate the root activity. Why did this person had high privilege, right? What next you have to do? Everything is very clearly allowed here in terms of analysis and recommendation. Now, all the person has to do today, right, is to just validate if this is fine. Still, GenAI is still in early stages if you see, right, we are still validating this. All they have to do is validate this, and single click of a button an incident will get created. Okay. So generally an activity that takes couple of hours, right, now it is now done a fraction of minutes, it is completed. Okay. So the future is even this will also get automated. The alert will come, automatically this activity will happen, incident will get created, and it will go to the customer, and if their automation is enabled, response also will get automated. Okay. So you don't have any human intervention in between at all. Yeah. So that's where the future is heading. So couple of years you will start hearing a lot about autonomous SOC, autonomous threat detection and response, right? So that is going to happen in next few years. We are heading in that right direction only. Yeah. Balan. So the third use case is security posture, right? So SOC team generally, right, threat detection and response team, we see everything. Okay. So since we are getting telemetry, we know everything that is happening in the enterprise. Yeah. And we are called the last line of defense. Okay. So we are sitting and we are watching everything, right? So there is something called first line of defense. So your antivirus, EDR, firewall, web application firewall, these are all considered to be first line of defense. Okay. They are essentially there to protect, okay, stop the threat, right? But so they are still not perfect. So that means something is going to always bypass and come, so that the last line of defense is there to catch and then alert the customer. Okay. Now, like I said, the first line of defense is not always perfect. Okay. So since we see everything, we can give recommendations to the customer saying, hey, your firewall is not good. Okay. It can be improved. Your EDR AV is not configured properly, right? So those kind of recommendations we used to give in the past manually. Okay. We used to do the analysis and we used to give a report after report to the customer. The customer also then takes action and all that. Now this entire process is managed by Agentic AI and GenAI. Okay. So here you see, right, firewall. So on the right hand side you see the score 4.33 out of 10. This is the overall security posture of that customer. Lower the better. Okay. So the lower, so the score is much better here. And firewall, you can see what is the score of firewall. The firewall score is much better. It is 5. Yeah. And you can see we are giving this trend for 3 iterations, last 7 days, 30 days and 90 days. Okay. So that you have a broader perspective. So perimeter security, endpoint security, identity access management, you see all these things, it analyzes and it tells what is the security posture of all these devices, and it also gives a recommendation. Balan, if you click, so it has analyzed all the threat. Firewall, if you look at firewall, what is firewall supposed to do? It is supposed to block the threat. Okay. But if it is allowed a threat, then there is something wrong with the firewall. So we are seeing all these threats coming out of firewall. So it does the analysis and gives recommendations to the customers to go and fine tune and improve the firewall, right? So this entire process of security posture management is now managed by Agentic AI and GenAI. Yeah. So Balan. So you can see all the layers of security comes here, right? No human intervention itself is there. Okay. Go back to the PPT. So to summarize, so quick summary of all the use cases. So machine learning for UEBA. So the benefit here is reduced false positives and improved time for detection. So that's where it is used. GenAI for triaging and investigation. I showed you the analysis, recommendation, everything. So outcome there is higher quality insights and faster MTTD. Again GenAI and also Agentic AI for security posture. You just saw that one. Here stronger first line of defense, right? Better ROI for the investments that they have made. Now since you see everything, then you should be able to tell the customer what they can do as well. Yeah. So that's where GenAI comes. Agentic AI, we couldn't do that today, slightly more complicated. We are using Agentic AI for proactive threat hunting. So what is proactive hunt? Okay, so you take a hypothesis, you create a scenario and you start the hunt. Okay, so this earlier it is done by people on the ground, highly advanced skills you need to do this. Today with help of Agentic AI, we are able to do the proactive threat hunting. Yeah? So we can tell at what time what we have to do, we can configure it, everything can happen in the back end, right? Automatically it will do proactively. So that is proactive threat hunting. The next is reactive threat hunt. Okay, so let's say you saw those alerts, one critical alert comes, very critical alert suddenly comes. The agent today is configured to detect some of these critical alerts and immediately start a hunt. Okay, it will go inside the enterprise, it will hunt, find all the information and it will give a quick analysis and recommendation so that you can take actions, right? So reactive hunting is now done by agent. Okay, and one more use case is, see today everything is automated. Okay, so now there is one side effect of this, right? Full automation is there. People today sometimes don't even know that the alert is coming, incident is getting raised, everything is happening in the back end. Okay, what if suddenly there is a cyber attack? Okay, the customer will start seeing that why I am getting so many incidents. Okay, the team can actually miss it. In the fraction of a second, this all can happen, right? Now the agent is monitoring this. Suddenly, if it sees a spike in alerts and incidents, it will notify us, saying that something is abnormal. Now you please look into it. Okay, so there also we are using Agentic AI. Last but not least, today agent in our environment is monitoring the people as well. Okay, end of the shift, it will generate a report and it will tell what is the performance of that particular engineer on that shift. Okay, whether those alerts have been handled properly, incidents has been responded properly, it will create a beautiful report. It will also help with the handover so that one engineer handing over to the other, it will be highly simplified. Okay, so that also is completely done by agent. And there are many more use cases which are going to come in future. So this, like I said, Balan, if you go back, so this threat detection and response as a landscape is changing significantly, and like I said, in 2 to 3 years we are going to see autonomous threat detection and response. We are not far away from that significant milestone. So thank you for the opportunity to present today. I hope it was useful. So we still have some time, so if you have any questions, we are happy to take the questions. Was it? Yeah.
A lot of discussion about MTT. They have mentioned about MTTR. Now, you are doing a lot of autonomous detection, not so much on resolution. Am I right?
So the resolution.
Right now. I understand everybody will get to that, but.
So if you go back to the previous previous slide, just go back, Balan. Yeah. So if you see SOAR, SOAR is security orchestration, automation, response. Okay, so that means that module is essentially responding to the threats. Okay, let's take an example. Your mission is, we have identified a malware in your mission, right? So once the incident is raised, SOAR can automatically quarantine that malware. Okay, right? If you are in the enterprise, SOAR can quarantine your laptop itself. it will take your laptop out of the enterprise for a brief period of time so that somebody can take action. So that is already there. Okay.
You mean the agent or the AI is doing that?
So
does it go through an approval flow? Is there a human in the loop?
Yeah, it goes through approval. So depending on the enterprise change and risk policy, what it will do is it will send an email, right? So they have to click yes or no, right? If they click yes, automatically action will take. Whether an agent is taking the action today, no. Traditional automation is in place, but pretty soon agent will start taking action. Okay, so that will be highly preventative mode. See this, if you see, this is reaction after something has happened. Okay, the agent will be sitting in the machine and it will take quick action then and there. Okay, so that you don't go through this cycle. Okay, so it will be done at the initial stage itself.
So actually, I have a question on the RAG model. Actually, if you go to the back slides, how this RAG model going to help for the maybe any incidents happen?
See, this is orchestration. Okay, so bunch of actions will be there. This RAG model, the LangChain is the one which we are using for the RAG. Okay, RAG is multiple input output. You will get it out. Input from your UI or any API. Output is you go to the LLM or in vector DB, get the data and give it to the LLM and get the response back and given to the API response back. This RAG is completely orchestration and even correlating also. So that is what RAG is going to do here.
So you mentioned the API. So can we give the there is a public website of the company. Can we give the API of the public?
No. We are not. See,
only
that's
internal
what
data we can give the
closed circle. So see, there is a data privacy is there. Okay, so it's all data has to be protected. We won't expose to the public APIs. It's all internal. It's sitting in our on-prem machines, and it's highly protected with airbag. It's highly secured. Okay, that is where I would say this RAG. Okay, and it's only the port and all right. We will be allowing to API to connect it to over there. And that is also highly secured with the validation of all the APIs. So that is what we are doing currently.
Thank you.
Thanks.
Hi, Mayur here, currently developer at SAP Labs. I want to know how did you validate the RAG framework and benchmark the data set on whatever model you used?
So that is where the data pre-processing is matter. Okay, so we are not providing all the data to model. Okay, so we will sanitize our data. What is required for us? Okay, right. See, you have 150 data. A number of columns will be there in the data. Okay, but we know as a business, we know what data is needed for us to detect or get the input, get the output from the LLM. So from there, we are doing the data validation and sanitization also. And then the benchmark RAG is it's allowing only the input whatever we are providing to them. Okay, it is not going to take all the inputs. Okay, it's a valid of, see, you have 3 APIs has to be connected to the RAG. Okay, only 3 APIs will be connected and will be respond back. Okay, that is where the RAG framework being designed.
So you are using an anonymization layer as
you are
before taking your input.
Yes, you are correct.
Because I am in the privacy team itself, so just want to know how you're working.
Okay, the same thing.
Hi everyone. So I have one question that come out of my mind and little frame that I have done with that. So if someone behaves like a normal user, but is actually a threat, okay, and there is no known virus or signature on that, okay, and how will your system catch it without making mistakes or invading privacy?
So can you please repeat it again? I had slight difficulty understanding. Yeah.
So if someone behaves like a normal user, but is actually a threat or intend to make an threat.
Okay.
Okay. And there is no known virus or signature, right? So how will the system catch without invading privacy or making mistakes?
Yeah. So let's say it's a malware, probably nobody knows about this malware, okay, right? It is still not identified in the wild, okay. So, but it has to do something, right? The malware is there to do something, okay. So, today if you see, there is something called fileless malware. So, earlier you used to have malware which is slightly heavy, okay. So, these antivirus and EDR tools will quickly identify and quarantine, right. But today if you see fileless malware, polymorphic malware, so there are different types of very advanced malware, okay. So, what it does is it's getting inside your machine, okay, either it came via phishing email, let's say through a PDF document or a Word document or some method it came inside, right. Now it is there, it has to do something, it can't simply sit there, right. A fileless malware, what it will do is, to sneak in, it came with a very light footprint, okay. Now what it will do is, it has to contact the mothership, we call command and control, it's called CNC. It will try contacting the CNC to get the payload, because if it has to achieve some objective, it needs that payload. So, it will go to the CNC. When it goes to the CNC, the system will detect, because it is not a normal behavior. Like I said, you are talking to a, like I said in my first slide, so there are three things I said: user behavior, device behavior, along with threat intel, okay. Now, this command and control mothership, right, it's a malicious domain, it's malicious, it's not a normal one. So, with the combination of all three, we will be able to detect, okay. So, even if I can't detect, let's assume that threat intel generally comes 24 hours or few hours later it comes, okay. Let's assume that this fellow is highly sophisticated. When this reached out to the command and control, still we couldn't identify, a payload has come inside, then the payload has to do something. It will start identifying, we call discovery, it will start identifying what is there in the enterprise, it will run certain commands, right. These are the not the normal commands which the user generally use day to day, okay. So, the UEBA will quickly identify that, hey, this is not normal, this is abnormal, and it will raise an alert. So, you have multiple options to detect, okay. So, that is where the criticality is to reduce the false positive. Lower the false positive, better detection. But if you have flood of many things, you will miss it, okay.
All right, thank you so much.
Any other questions? Okay, brilliant. Thank you so much. I hope it was useful.